Going back, it seems like hours ago for everybody. Dr. John Clark put me into the FCC. Dr. Clark was the inventor of the Tyros weather satellite system, the first one in history. It's still running. He's long since passed, but he's a wonderful man. And the end of his career, he was the dean or the chancellor of the Florida Institute of Technology. What's important about that? Gordon and Conrad, astronaut guys, and as well as some others, we used to have these bullshit sessions all the time. What's next? And these all retire from space. And in 1999, I was making a lot of money. My kids were in college and doing really well. And I was unhappy. I was bored. My people managed themselves. They didn't need me around to tell them what to do. And I was unhappy at home. I just personally just unhappy. I picked up, and John retired, as I said. John Clark retired as the dean of Florida Institute of Technology, which is the astronaut school. That's the astronaut graduate school. I called him. And I said, John, and he said, I know what you're going to ask. And this guy knew me really. I said, you know you don't. He says, you're going to ask if you can get in. And I said, yeah. And the minute I said it, I realized I've done something that violated my own ethical code. But he led me right to it. He said, look, he said, you know me. He said, I love you. And if you want me to do this, I'll do it. You're in if you want to be in. I just want to ask you one question. Most of our astronauts in the system are former military. They're relatively young compared to you. And they have families and they're attending school here on limited military pay. And they're devoting their lives to this. Which one of those people would you ask me to give up their seat to put you in? I was so humiliated.
Oh, yeah.
And he said, I still remember him saying, I imagine your face is red. I said, John, I should never. He said, what? He said, I figured one day or another you were, you're like I am. He said, we're all crazy to get into space. Most of you, probably all of you, will have the opportunity.
Yeah, I agree with that. So we've got 8 minutes left. Let's get some questions and answers. If people want to put some questions into the comments, and then if Will or somebody that's in the main room there can go and type in any questions that people ask in the crowd, we can make sure to address them. All right, can you see the comments there, Brian?
I sure can. Here, let's see. This is Yuvan. Can you raise your hand?
Or, no, you can see the questions within. Oh, yeah, there you go. Yeah.
There we go. Okay. A lot of space tech companies surfacing within this decade. Everyone is in a chase, a sort of space race. Absolutely. Of course, space is big enough for all of us. What qualities or practices in a company do you think will make it stand out among its competitors? I'll say a couple of things, and I'll give you a brief answer, but I want to preface it by saying I doubt that 99.5% of the people in these startup companies understands the first thing about what it takes to field space systems. We talked earlier about the invaluable data proven by ground sensing satellites. Crops are managed, water sensors, weather sensors to protect against hurricanes. People are offering things like hyperspectral cameras, which is just a way of saying wide bandwidth. They're offering things like methane sensors. We just put up a methane sensor satellite. But none of them is offering a rocket. They all have to beg, borrow, or steal rides to do their prototyping. Right there, there's a competitive bottleneck. If you think that there is a good opportunity, go and talk to somebody who does hyperspectral sensing. Go and talk to the meteorological satellite operators and get a grounding in it. I've seen outlandish stuff. I get hit with it actually all the time. What it takes to be a winner in this sector, luck. And as Reagan says, you manufacture your own luck. Fortune favors the well-prepared, as they say. When you're going to market, and we talked a little bit about coming up with a solution for a non-problem, when you go to market, you need to understand the past, present, and future of what you're offering. I've actually tried to buy the Iridium constellation. Most of you won't remember it, but it was satellite phones. And they putatively could operate anywhere on the planet. I was FCC, and I knew it was bound to fail, and I wrote a couple of papers about it. 10 years later, they failed. $9 billion out of a $10 billion budget spent on dinners and airplanes going back and forth from DC. and 1 billion to fly this stuff up. And I see Letitia nodding wisely here, which is very encouraging. What are we going to need in space? We're going to need very good vehicle to vehicle communications, and we're still struggling with that. NASA has a thing called the Deep Space Network, which is optical, but very little good science has been done on cell phones between spacecraft. One of my clients, like most of them non-paying, but equity offering, is developing a lunar communication system, which consists of moving mobile cell towers. They're just little vehicles, and they talk to each other. They use radar to identify each other. They talk to each other and offer cellular communications on the moon. Nobody's developed these things yet. These are enormous opportunities because guess who's sponsoring most of them? The government. The government will be underwriting all of the early habitation on the moon. The government will be underwriting the new generation of medium-sized and geosatellites. And there are a lot of opportunities there for technology people, for not necessarily deep technologists, but people who understand the relationship of various components in a system. I'd say the qualities you need are smarts, a willingness to listen, a willingness to let people who are smarter than you about that subject tell you what to do, and a willingness to keep your nose out of things like ordering people around and doing all that startup nonsense. Think long and hard about the objective. In systems engineering, we talk about the requirements. That's not the beginning of systems engineering. The first thing I teach my students in all of my classes is you design what is it we want to do, and then we design the spacecraft.
What's the problem that we want to solve?
Yeah.
Or we get lost in the features, but what is the problem? Yes.
And being in a hurry in the space business it's for fools.
I came from digital marketing technology and sales, so things move pretty quickly there. But I'm starting to get climatized to the spacing. But I think I'm bringing some speed to it too.
There you go. Yeah, I was actually the guy that tried to buy Iridium at the end of that. Okay, next question.
Does anybody from the audience have any questions? Just type in the questions in the comments right here. Or you know what? Why don't you just take it off mute? You just take it off mute.
Hello, we have an audience question. You just have to speak into the laptop.
Yeah, it was very nice listening to your talk, and I feel like I can listen to it whole day. Yeah.
It's very kind of you.
You could talk all day, believe me.
But I'm not making your brain.
Yeah. So I'm working as a postdoctoral fellow in process system engineering in University of Regina. Yeah. So what is Avro's approach on sustainable space exploration? If we consider, as my research areas, energy and fuels, is it regarding the fuel efficiency when we talk about the space mission, or making it economic, or how we can make it relevant to Saskatchewan, since we have a lot of biomass and we can produce hydrogen, which is one of the fuel for space exploration, and the kerosene grade, aviation grade kerosene. Can you comment on that? And
what's your name again? Yusuf, pleased to meet you. I think at last count, I lost count actually, but I think you just asked 7 questions.
I think he's talking about the fuel. Actually,
All of which,
he was asking.
All of which I direct you to the actual expert on those things. I can talk about them. It's right next to you on the screen. You need to be talking with Reagan about that.
Yeah, and so the ICED program where we delivered our Mark I rockets, it includes a hybrid rocket system that the goal is to be more efficient with fuel. At the end of the day, fuel efficiency is the whole point, is reducing the cost per kilogram to make efficient launches into space, to make it more economically feasible for specific type of projects to be effective. But there's other elements like autonomous systems and control systems and AI models that can actually expend the fuel at certain times based on machine learning type of environment. So those are definitely, like our Mark II program is definitely going to have a lot of autonomous systems, other elements that the goal is to be extremely efficient with fuel. We're also working with another company on a 2-stage space plane to deliver payloads from a space plane, and they want to utilize our ramjet within their stage 1 system. The ramjets themselves are There's less maintenance costs, they're better on fuel. And so the goal is bringing down the cost per kilogram, and that includes fuel efficiency, maintenance, efficiency in general. The goal is reducing the cost, being operational efficiency. With the rise in market demand for LEO and as Brian mentioned, LEO, like companies that stand out are the ones that are dropping down costs for operational efficiency. So, and fuel is a part of that.
Okay, the last two questions. Can we make it relevant to Saskatchewan since we can produce hydrogen from biomass that we
Gotcha.
have?
So the hydrogen element. So part of this is a hydrogen element. We're doing our engine maps on including hydrogen within this 2-stage payload delivery system. So hydrogen is definitely a part of that.